Hey everyone, welcome back. I hope you have subscribed to this channel by now. If not, this would be a great time to hit the subscribe button. And this is also a great time to hit the thanks button and show your generosity. In this video, I am going to provide you a bit more clarity about data science versus data analytics versus machine learning versus AI and so on. And again, this is going to be a very short video, so I'm not going to go into a lot of depth and details. Go ahead and Google search for this topic if you want even more clarity. I'll see if I can do a good job in at least educating you to the point where you understand the difference at a high level. And more importantly, I want to show you a couple of things. First of all, where is the overlap between these two, and what industries or what type of domains where data science and machine learning applies, and also, of course, what you should be learning to be mastering these fields. There's a lot that you can learn, but I'll show you the core basics. And I'll also end this with my proposal of how you should be structuring your learning journey if you want to master data science and machine learning in general. So without wasting your time, let me just jump into defining what data science is. Well, the name itself says science in it. That means there is a structured scientific approach in answering a data question. That's what data science is. What does scientific approach basically mean? That means you come up with a hypothesis and you try to validate your hypothesis using a designed set of experiments. That's what data science basically means. So it's a scientific approach to extract insights from data. This is not just about answering a question about, okay, what was the revenue for us last quarter? This is also about, okay, how can we forecast what the revenue is going to be, in the next quarter or the quarter after that. And so that's all part of your data science. And a subset of data science is data analytics, where you have a specific question that you would like to answer. So it's always about draw specific conclusions. It's a good example would be you have a product, you have a web product, and you are doing some advertisement, and your marketing team is asking you a question about, okay, how many people did we bring to the landing page, and of those, what the conversion rate is, and which means how many people filled a form, for example. So that's an easy question. You have a specific question, you have your data from last quarter, for example, and then you're just looking at, okay, how many people fill the form versus how many people are coming to your landing page, right? So this is a data analytics, obviously the simplest example I can think of right now, but at least that gives you a good idea of what data analytics is. Now, when it comes to artificial intelligence, that's also a pretty broad field, and of course it overlaps with data science. And artificial intelligence is where machines are trying to mimic humans in terms of reasoning. That's all. So machines are learning about how to reason like humans. That is what artificial intelligence is. And there are certain techniques as part of artificial intelligence, and machine learning is one of the approaches or techniques, if you want to call it, that is a subset of artificial intelligence. And machine learning, in summary, it just learns from data. Machines are learning from existing data. That's machine learning. So of course, it uses algorithms that have the ability to learn from data. And again, data science overlaps with machine learning. That means there are tools that machine learning provides that can answer the questions that you're trying to answer as part of your data science. But please remember that machine learning is not equal to data science. Yeah, it's just a tool that can help you in performing your data science. And subset of machine learning is deep learning. It's again a set of algorithms that are using neurons or artificial neurons. That's pretty much it, right? It's again algorithms learning from data, except in this case the algorithms are based on artificial neurons. You do not need to learn deep learning to answer certain questions that are part of data science. Again, there is an overlap. You can use certain tools, but data science is not equal to deep learning, okay? Now, what industries benefit from data scientists working in these organizations? Well, this is a very busy slide with a lot of industries right there, and this is even not even tip of the iceberg. Like, think of any industry, it doesn't matter. You think of pizza delivery, right? There is data science in there. You think of food science, there is data science in there. You think of healthcare, drug development, personalized healthcare, right? So data science can definitely help you there. Marketing, I just gave you an example. Targeted advertising, this includes machine learning algorithms powering up data science. Fraud and risk detection, again, anomaly detection algorithms that are both traditional and also machine learning based can definitely address this type of applications right there. Government, a lot of fields, sub fields as part of government. I just gave you tax as one example. Social media, of course, sports scouting, for example. So at least in the US, there's NFL, like American football, Major League Baseball, NBA that everyone probably knows about. Where do these players come from? How does a team decide that certain players should be part of their team? How do they recruit them? Well, it's not like they just look at only one college. They actually look at their journey, that player's journey throughout their high school and college, and there is a lot of analytics that actually goes into the scouting process. Again, please watch the movie Moneyball. I think it's Moneyball. It talks about how the Oakland A's used data analytics even a couple of decades ago in their recruiting process. So it's a great movie. I love Jonah Hill. He's part of the movie over there. Anyway, getting back to the topic. So sports is another area. Medical research. Again, I focus on microscopy. So my data comes in the form of images. And oftentimes, my data, the answers I find are via machine learning and oftentimes deep learning, right? So that's the technology that I'm into. But let's say maybe a couple of years from now, I get bored of what I'm doing. Hopefully not, but let's say I get bored of what I'm doing. Now I look at, okay, what else? Where do I go? Maybe I'll think about going into finance. I'm into marketing right now, by the way. I'm not doing original research. I'm looking at marketing data, but then I'm also looking at images and everything. So these two, I check my boxes. Now let's say I want to go into autonomous driving. Or okay, for the sake of simplicity, let's say I'll go to finance. Now, first thing first, I need to learn the technology, which is, okay, what other algorithms are there? Because I cannot just use deep learning for my finance. Maybe I need to learn a bit more about the traditional algorithms like ARIMA and SARIMAS, autoregression, by the way, based algorithms, for example. I need to learn how to do forecasting. But more importantly, I need to learn more about the domain itself. Finance, like what do we mean by derivative market? Like what does that look like? What are hedge funds? And it's not just simple stock market forecasting, right? You need to learn a lot more about the domain so you feel like you understand the market. And then, of course, once you get into it, then you learn more about it. But domain knowledge is very important. Okay, so many areas, but where do you start? Like, what do you learn? What type of skills do you actually need to be successful at these jobs? So first of all, data science, you definitely need math. We're talking about data. So of course you need to know math. Of course you need to know statistics. These two, again, I'm talking about basic statistics, nothing too fancy or advanced. You don't need a PhD in statistics, but you at least need to take a few courses as part of your bachelor's and preferably master's. If not, at least go and get similar knowledge by reading books and taking some courses online. You definitely need domain knowledge. You cannot just go and work in shipping industry if you don't know a thing about what shipping industry looks like. So you need to get the domain knowledge. And of course, programming, that's the easiest part. And database management, subset of programming, let's say you need to learn that. And if you want to go into data analytics, let's say you want to work in a financial department at any industry, it doesn't matter. Every industry has data that they want to look at to understand what happened the last quarter or so. But for that, you need to be very good at data presentation. It's not just about collecting data. It's not just about running your code. It's more about data presentation. Now you need to be creative in terms of how to wrangle the data and what is the best way to present that data. Is it a bar graph? Is it some sort of a violin plot, right? So what is the best way to present the data that the audience that you're presenting it to will be able to easily understand without a lot of explanation? So that requires a lot of soft skills, right? For you to be able to talk about it, to present data. So again, it requires different set of skills. You need to be comfortable with, for example, Power BI. Maybe you're not a coder. Maybe you want to use Excel and Power BI and PowerPoint presentation to do your presentations. That's fine. You can be a data analytics person because it's a smaller domain. It's not much big. So you can just focus on a few tools. Maybe you can just use Google Analytics tool because they do all the analysis and all the parts. You just need to know exactly what the right metrics are and how to present them. So that's data analytics. If you want to learn to code, then I definitely recommend R for statistics. If you already are familiar with R, great. If not, Python is probably enough. You don't need to learn multiple languages. Python is probably enough. And especially focus on certain libraries like SciPy, NumPy, and Pandas to wrangle the data, basically. And SQL for database management. And if you want to present these, again, Google Charts, Tableau, and Grafana are some of the ones. Again, new platforms will show up all the time. So identify something that works for you. In fact, my suggestion is if you're interested in data science or data analytics, whatever it is, go look for a lot of job postings and see what they are requiring. Do they talk about Tableau or one of these as a requirement? If so, go ahead and learn that, right? So that's how I learn what these industries are looking for, what type of skill set. And then if I really am serious about going towards financial market 2-3 years from now, this is the time I should be starting. Right? If you're changing your domain, then this is the time you need to start learning about the domain, about what tools they need, and the best place would be job descriptions because they clearly tell you, most of them, exactly what skills are needed to perform that specific job in an efficient way. Okay, now moving on to the artificial intelligence side. Again, you need advanced math. There is a lot of math that you need to be thinking about, and probability and statistics, definitely, like naive Bayes, for example. That's probabilistic approach, so you need to know exactly what that means. Programming and data technologies, to if you're going to deal with big data, then of course something like Spark would be useful. And if you want machine learning focused, again, applied mathematics, maybe physics, again, it depends on what domain you want to get into. Natural language processing, again, domain specific. Videos and images, like I mentioned, currently I work with a lot of images, and I'm fascinated by image processing. That's exactly what I do on my channel for the most part. And that means you need to be comfortable in terms of understanding what different video formats are, what images are, what does a pixel value basically mean when someone says pixel value, what does segmentation mean, and when a pixel is quantized like 0, 1, 2, and then you have nothing else, and the image looks black on your screen, you need to understand why. Yeah, if you're not comfortable with working with whatever data you're working with, like in this example, images, then you need to spend more time in brushing up those skills. Just copying code from GitHub, changing a few things, customizing it for your own images, and then calling yourself a deep learning engineer or data science engineer is going to turn out to be a very bad experience for you in future when you go to interviews, or even, God forbid, you get a job and then you're asked to do certain tasks. You should be comfortable with all of these, right? So what coding skills? Again, Python, SQL, and in addition to that, scikit-learn, scikit-image for traditional machine learning, TensorFlow, PyTorch for deep learning. Okay, this is a lot of stuff that I'm throwing at you. And if you are someone who is getting started or recently got started with coding, then I am going to give you my perspective of what the best way is for you to get started. The best way is to spend a lot of time on Python basics. This is where it makes or breaks, right? I mean, this entire journey. The first 1 month, if you're actually getting started with Python, is not going to be comfortable because you're learning a lot of very abstract stuff. What are loops and what is while loop, what is like if conditions, if and else, and all that stuff. It may sound a bit weird because you're not working towards a specific project, so it gets a bit boring because you're not creating something new. But once you go past the first 1 month, then you will start to enjoy, believe me, you'll start to enjoy the coding part, and then you can slowly get into functions and classes and make sure your journey for this stage definitely includes functions and classes. Yeah, you need to be very comfortable with those. And this is very easy if you structure your journey. And if you expect to get too much done in 1 month or 2 months, then I think you'll be disappointed. Get over that hump first, okay, of going from being bored to looking forward to your coding time every day. Put 1 hour in your calendar so you at least make sure you work on these, or 2 hours over the weekend, for example. Okay, now you're comfortable with Python. Then the next step is to get comfortable with probability and statistics. Hopefully you already have some basic knowledge in probability and statistics from high school and college. On top of that, just build additional stuff, add additional stuff like multivariate, Gaussian, Bayesian. They may sound very difficult, especially if you are coming from biology background or some background where you probably didn't talk about these, but try to find books where they explain these in plain English and then get into certain examples. I absolutely hate books where they just use equations and they say, oh, this alpha equals to this, beta equals to this, gamma is something else, right? So those are not the ones. Find ones, go to a library, go to bookstore where you can sit and read. I know in the US you can go to Barnes and Noble, sit and find like all these books and find the one that you like and then purchase that one. Yeah, purchase the one where they talk about stuff in plain English and then give an example, right? So those are the easy ones. Okay, so now you master your probability and statistics, and the next step is going to be brushing up your Python now again, right? So Python for data analysis is what you need to do next. That means new libraries, SciPy, NumPy, Pandas for data wrangling, and Bouquet, Seaborn, and Plotly for data presentation. And you don't need to learn all of these. My recommendation is probably Seaborn is good. Plotly is also very good. It makes your plotting easy and also interactive and makes it easy to share with others because it generates HTML. Okay, so now you have Python kind of figured out. Yeah, at this point, you should be able to just go to Kaggle, for example, look for certain projects, and then go ahead and start working on those, but not obviously machine learning, but basic ones. Yeah, or not even Kaggle, like just some think of a scenario. Hey, I want to present this data. You have a bunch of data. You want to present it in certain form. You're not doing any forecasting. You're not doing any predicting. You want to take some data and present it, right? So this is exactly where you would be doing that type of projects. So even on Kaggle, you have lots of data that you can take and only focus on data organization and data presentation. You're comfortable here? Now go to the next step. You have already learned how to work with data in this step, in the previous step. Now extend that with answering a question using machine learning, for example. Focus on scikit-learn, scikit-image if you're working with image-based data, but these are the two libraries that I would focus on. Like the algorithms that you would be using are random forest, linear regression, and it can be support vector machines and gradient boosting. So these are the algorithms that you would be focusing on right here. Learning about these algorithms is an absolute must before you go to deep learning. If you only learn deep learning and you apply for a job, you will fail miserably, because deep learning is a subset of machine learning, and machine learning is the technique that you think about first when you have data. And if you have a lot more data, and if you have some other specific type of job where traditional machine learning is not enough, then you go into deep learning, right? So that's only when you go into deep learning. You cannot just focus on deep learning and call yourself a machine learning engineer or a data scientist. Deep learning comes after you're done with your machine learning, you're comfortable with this, and then comes Python for deep learning. Go ahead and I almost said pick one, either TensorFlow or PyTorch. Nowadays, it's becoming almost a necessity for you to learn both. So just focus on one at a time, but try to learn both. The concept is similar. The coding is slightly different between these two, but once you learn one, the other one is easy to switch to. There's a lot of code on GitHub that you can just go copy and learn from it. Yeah, of course, follow my tutorials, and all my code is also on GitHub, and then expand your knowledge by looking at even more code. Now, what type of domains that you should be looking at whenever you jump into this area like Python for ML or for deep learning? Make sure your projects are focused on specific domain of interest. Don't just jump from one to the other to the other. I know I have a tendency of presenting my videos in a I covered I guess forecasting like in a few videos, but bulk of my videos, as you know, are on image processing, image analysis, object detection. So if you're into autonomous driving, if you're into medical image processing, bioimage analysis, if you're into satellite image analysis, all of those can be covered if you watch my tutorials. But if you are looking for some domain specific financial analysis, I haven't covered that yet because I'm still I don't have the domain knowledge yet. Maybe I'll teach myself and then I'll start doing those tutorials soon. And the way I learn is by teaching. So when I put something on my calendar, okay, I need to do stock market forecasting, right? So that means the 4 weeks before that, I'll teach myself what stock market is. Of course, I think I know what it is, but then there's always more to learn. So this is how I actually structure my learning. So get the domain knowledge first, and then put your fingers on the keyboard for coding. Okay, I think that's turned out to be a little longer than I expected. I know I was talking quite a bit, but I hope you found this to be useful. Again, guys, please do hit the subscribe button. Again, also thanks button if you're generous. Thank you.